Recording.
Sir, should we start?
Yeah, Nitik,
Or-
I guess we can start. Let's go ahead.
So, hello everyone. Today we will be talking about computer vision and some basics of OpenCV. So, basically today we are going to cover what kinds of images that we have, how to write and read images in using your Python code. We will discuss what is color space and how we are going to use it. We are going to learn what is thresholding and masking. So before I do, let's start with the introduction. So when we talk about computer vision, we actually mean is image processing. Image processing is a method to convert an image to a digital form and perform some operations on it in order to get an enhanced image or to extract some useful information from it. So what I basically mean from this definition is like you give me an image, I'll I'll take that image, put into a code, and I will give you some information about it. For example, like you have Google Lens in your phone, you can point it to an object and it will tell you what is it, whether it is a dog, whether it is a monument, whether it is what kind of food it is or what kind of shop. So that is what we mean by computer vision or image processing. And for in our case, we would be using an image and we would be processing to get very limited very beginner friendly process, like we can find what color is it, what kind of shapes are in it, like triangles, rectangles, circles, what shape of that particular triangle or circle has, and on based on that we can do some task which would be clear in further workshops. So moving forward, let's, before talking about what is image processing in depth, what are the things that are covered in image processing, let's talk little about what types of images that we have on which we can work on. So basically we have three types of pictures or images. First one is binary, second one is grayscale, and third one is RGB, that is the colored, gray or black and white. So a binary picture is an array of 0 or 1. So whether there's a white or there's a black. Like you can see here, there's nothing gray. There are some teeny bit of white pixels, or you have either black. So how is this image stored? This image is stored as an array of 0 or 1. The information in the array is only 0 or 1, whether there is a white pixel or there is a black pixel. Now on the other hand, we have a gray pixel. Here we have a whole lot of spectrum of grays. So we can have more information in our picture or in the image. So here you can see we have white, we have gray, we have light gray, we have dark gray, and some spots we can also see black. In this type of image, we have an array which stores a value between 0 and 255 with both included, where 0 means that it is completely black and 255 means it's completely white, and in between there is a whole spectrum of gray. So smaller value means dark gray, whereas higher value means light gray. Moving forward to an RGB picture. So an RGB picture or image has three channels. So first channel is red, another one is green, and another one is blue. So in an RGB image, we have an array of pixels, and a pixel is itself is an array which consists of the value RGB with a spectrum from 0 with value 0 to 255, whether it is completely red or it is black. So here you can see, like if we have a image of cat, it is splitted in three channels: red, green and blue. So if you want to, for example, like we have white, so what we can, how it is splitted is, it has complete 255 value of blue, 255 value of green and 255 value of red, and combining all these values we get our white color. For black, our red, green, blue, each picture, each value is 0. So on adding them up, on adding those three colors up, we get a black. So moving forward, now we would be reading and writing images using Python code. So here we would be using Opencv to use or open images in our code. And to do that, we have a function called cv2.imread, in which you give the path of the file and a flag. Now, what is the flag? The flag is whether you should read the image as color or as a gray. So I would be showing you that how it is done by using a demo. Bhaiya, can you see my whole screen, or you can just see the browser?
Yeah, we can see your whole screen.
Yeah, cool. So here, so now what we do is we import our OpenCV using the command import cv2. Then we take some path, like I have my picture stored in this folder uh, where resources, and there is a image called ppxnh, and I have given the path here in quotes, and then I have passed that path as a variable here. So when I run it, okay, yeah. So see, what is happening here is I'm just reading the image and not doing anything else. So the Python code is executing and saving the image in the as a form of variable. Now, now what is in being done? The Python code is running, and Python code is reading the file from reading the image from a file. Now, if I want to show this image using the Python code, I would have to use another function called cv2 cv2.imshow, in which I have to give some name of the window in which it would open, its name, and the image variable. So here I have another demo where I read the image and then I show the image using cv2.imshow image, and there are two other functions, cv2.waitKey.0 and cv2 destroy all windows. This is added so the window which opens, it can stay open until I do anything else. So if I run it, so you can see I haven't opened an image using my Python code. And if I press any key, it would close. So let me do it again. This time I will press a key and it would close automatically. See. So moving forward, we would be now discussing how to save an image. Suppose I have an image, I've done some manipulations on it, I've resized it, I have masked it, I have thresholded it, or uh, converted its color to different color space. So now I have a variable. Now I want to save it as image. For that, I have we have the function cv2.iamWrite, in which you have to give the name of the image by which you want to save by it, the name by which you will save it, and the image variable. So I have here, I am importing cv2. I am taking a path. I am reading the image using that path. And now if I want to write it, I have to use the function cv2.iamWrite. The name by which it should be saved, here it is newly saved.png, and it would be saved under the folder resources. So you can see that there is no such image as of now, but when I will run this code, it would save this image over in this folder. So let me run it, and you can see a new image was saved. So here I have provided the code for the same. Now moving on to the color space. From here we would be introducing some color spaces which would be used in image manipulation. So first of all, what is a color space? Color space is the term for a system that uses a specific color model to translate color into numbers. Because we cannot save colors as like red, green, light green, red, blue in our code, in our computers. We need to convert those colors into some numbers to save them and send them, and so other people can also open it by using the same formula for converting that image from numbers to the color. So for that we use color space. So we would be the color spaces which we would be interested would be RGB, BGR, and HSV. So BGR and RGB color space. In this color space, colors are stored in three different color channels, namely red, blue, and green. So like here I would use I have a color, say red. Now it would be saved as in numbers. So how it would be saved as is, it would be saved as R, G, and B value. So I know that it is primary red. So it would be R channel would be 255, green would be 0, and blue would be 0. So this is how your RGB works. It converts a color into three coordinates of red, green, and blue. So let me take another example like blue. Blue would be your, as a number, blue would be saved by RGB space as 0, 255, and 0. And green would be saved as your, as you can already guess, it would be 0, 0, 255.
ये blue और green उल्टा हो गया है.
Blue green alternate. I mean,
Yes, bhaiya.
replace it.
Okay, yeah, you got it. I did it on
Yes, bhaiya.
purpose. Nice. So this would be 0 and this would be 255. 0. Now in Bjar color space, the format of saving just changes. So first would come blue, that would be 0, green would be 0, and red would come at last. Just the where it would be saved changes. And blue would be 255, 0, 0, 0. And your green would be 0, 255, 0. Right? Like blue here red is 255, here blue 255, here green 250. Yeah, cool. And now the combination of the colors, like I have some another color like cyan. Like cyan would be a combination of green and blue. So here cyan would have some values. Cyan would have some values where red would be approximately 0, green would be some greater than some value in green, it would not be 0, and neither it would be close to 0. And same goes for blue, it would not be 0 and it won't be 0. Like for example, it could be 0, 255, 255. We would get a very vivid cyan. Now we would move on to HSV color space.
Natik,
Excuse me, भैया.
हाँ बोलो.
I have a question.
Yeah, sure.
That मतलब कि जब हमारे पास RGB कलर स्पेस था तो फिर VGR में तो बस ऑर्डर चेंज है, तो फिर उसे बनाने का जरूरत ही क्यों पड़ा? लाइक ऑर्डर
Yeah.
चेंज करने से तो फर्क नहीं पड़ता, जो अलग ही बनाया हमने.
Good question. So what happens is, what's your name?
श्रुति झा.
Okay, Shruti. See, what happens is when we have images in our computer, it is saved as RGB, but we would be using a module called OpenCV. So when you read the image, it gets converted from RGB to BGR. तो मतलब तुम्हारे कंप्यूटर में तो RGB है, पर जब तुम कोड में डालोगे तो OpenCV उसे BGR में कर लेता है.
Okay,
तो
got it. Thank you.
Yeah, cool. So moving onward to HSV color space. Here we don't have combination of 3 colors like blue, green or red. Here we have hue, which tells what the color is going to be. Like in this picture, hue tells you what would be your color. Like it would be like green, blue, purple, red. Saturation would tell you how further are you on this scale. Like you would be close to white or you would close to the color. And the value, HSV value, would tell you whether you would be close to that dominant color or to black. So what happens is, like I have a hue of red, like red is close to I think 0. If I have a saturation of 0, that means it would be white. And if I have value that is 0, then it would mean that it would be black. So what is the difference between HSV and RGB? In RGB, your color is saved as combination of blue, green and red. In HSV, your color information is saved as the dominant color, the saturation of the color and the value of the color. So the basic difference you can see here is that there is only one information in the array which is dedicated for the color. Other two are defines the intensity of the color, and the value, which is chromatic notion of intensity. So like if I go back and get to Hsv color codes, like I have read 255 convert, so its hue is 0, saturation is 0, and value is 100. If I change it to green, its value is 120. So only there is one parameter which corresponds to the color in Hsv, whereas in Rgb you have to take care of 3 parameters for colors. That is red, how much red is there, how much green is there, how much blue is there. So you must be thinking why we use Hsv and not Rgb. So why we use Rgb and not Hsv. So the thing is, Rgb is used in our displays. Like we have in our display our red pixels, green pixels, and blue pixels. So it is very easy to produce images using our display. And Hsv is useful for our codes. Like we want to segment. Like I have an image, a colorful image. Now I just want to know where are red. Then it would be useful. We can use Hsv Color Space for that, for segmentation and masking. From here onwards, Ariman will give you some demos on color space. So over to you, Ariman.
Yeah, thank you, Natak. I'm just sharing my screen. You can stop sharing. Okay. Is the presentation visible?
Yes, Bhaiya.
Oh, cool. So, Natak introduced you. Okay, first of all, my introduction. I'm Ariman Gupta. I'm a student of electronics engineering second year, and I'm a member of robotics club IIT BHU. Now, Natak introduced you to some color spaces, BGR, RGB, and Hsv. Now, we'll talk about how we can change these color spaces using OpenCV. First of all, why do we need to change these color spaces? So, as Natak also told you, like we perform different tasks on different types of color spaces. Like if we want to perform segmentation and filtering, we prefer using Hsv formats instead of BGR or other things. Okay. So yeah, in OpenCV, we have a function we called as cv2.convertColor, in which the arguments are the old image, which we want to change the color space, and a flag. Flag determines what change we want to make on the image. Like there are 3 simple flags which I have written on here. You can see that if you want to convert the image from BGR to grayscale, then you can use the flag this cv2.colors_BGR to gray. And similarly, if you want to convert it to RGB, it is BGR to RGB, and if you want to convert it to Hsv, then it is BGR to Hsv. These 3 are very commonly used flags while changing color spaces, and the result you get from this function is the new image in the new color space. So let's see a demo on this. Yeah, so I've written a similar code here. You can see that is my VS Code visible, right?
Yes.
Yes, Ariman, it is visible.
Okay. So yeah, you can see that here in my code, I have imported one image using cv2.m, and then converted the image to different formats. First of all, I've converted it to grayscale image using BGR to gray, then to an RGB image using BGR to RGB, and to an Hsv image. And then I've shown all 3 formats, and let's run this code. Yeah. So you can see that it is the original image, and this is the one second. This is the RGB image. You can see that what change has happened. Where it was blue in this original image, now it has converted to red. And where it was red in the original image, it has converted to blue. And the green region has remained almost the same. In the grayscale format, you can see that it's converted to a single channel of pixels varying from 0 to 255. So the image is not in a BGA format anymore, and it is a grayscale image. And this is an HSV format. Yeah. Okay. Yeah. Before we move forward, let's talk two more important techniques we use during image processing. They are resizing and cropping. You can easily understand what they mean by the word only. Like resizing means to change the size of the image, and cropping means to crop a particular section from the image. So to resize an image, OpenCV has provided us a function cv2.resize, and there are two ways to resize the image using OpenCV .resize function. One way is that we pass an image and we pass a new pixel value. You can say that the size of the image that we want. Here it is new x comma new y. So if you pass the image and the new size you want, you will get the desired image, which I'll show you in a demo. Yeah. So you can see that this is the original image which I imported, and I've passed a size of 300, 200. So it has converted the image to a size of 300, 200 pixels. And the next way of using cv2.resize function is in that you pass the old image and you pass a value. You can say a point. It is a placeholder, which is basically it is an anchor point about which the image will be resized. And you pass a ratio, fx and fi. We have to pass two ratios, which means that how much you want to change the size of the image. That is determined by fx and fy. Yeah. So you can see in the code. Yeah, you can see that I have passed the image 0, 0 as the placeholder. We generally use 0, 0 as a placeholder only, and no other value. And you can see that I have passed 0.5 in both fx and fy. This means that the image will be converted to half of the original size of that original image. Okay, so let's test it out. Yeah, you can see that this is the original image, and this is the resized image we have got, and it is half of the size of the original image.
What is placeholder in an image?
Placeholder is basically like you can think about it as an anchor point about which it will consider changing the size of the image. Which point it will take as a origin. Sorry.
We can call it a center.
Yeah, you can call it a center, but more precisely we call it like using an anchor or a placeholder. The basically about which this change of size will happen. And we generally use it as 0, 0 and nothing more special about it. Okay. So the next, So the next thing is cropping. Cropping is, OpenCV doesn't give any special function for crop. We generally crop an image using NumPy slicing. I hope you guys have an idea of NumPy as it was introduced in the Python workshop. But if not, then also it's not a problem. In NumPy slicing, what we do is we pass the size of the array. What size of the array we desire. So you can see that for x, I passed it as 10 ratio 900. So it means that I want to start the array from the 10th index and go it to 900th index. And in y, I wanted to start from 120th index and go it till 700th index. Let me show you a demo of cropping. In the code, also you can see that I passed 100 ratio 500 and 200 ratio 300. So basically in X it will start from 100th index to till the 500th index, and in Y it will start from 200th index and it will go till 500th index. Yeah, you can see the results here. Basically, it has cropped the image from this side, and it has taken in the Y also. You can see that what the change has happened. It is basically a crop section of this particular image. I hope resizing and cropping are clear to you guys. Okay, so let's move forward. Yeah, coming to the analyzing and processing part. In analyzing and processing, we generally prefer converting the image to binary format. Why do we prefer to convert an image in a binary format during image processing? The main reasons are that in a binary image, the pixels are either 0 or 1. So basically, when you process the image and use different OpenCV functions in that processing, it is computationally very efficient since it contains only two values, either 0 or 1. And also, since the image is binary, you can choose a particular area of that image, which will be your area of interest, and the particular area of the image which you want to process and apply some functions upon. So it allows us to focus on the particular area of interest on that image. You will understand this more clearly when I will explain you thresholding and masking. Yeah, what we use to convert an image to a binary format, we generally use two processes, thresholding and masking. Thresholding is used to convert those images which are in grayscale format, and masking is used to convert those images which are in RGB format. And let me tell you that thresholding and masking are the two techniques in OpenCV which you will use most of the time during this event and in future events also. So pay your attention here. Okay, so let's first talk about what is thresholding. In thresholding, it generally means partitioning of an image on the basis of the grayscale values of pixels. You can understand it like an image is made up of pixels, right? And each pixel has a value. So if the value of that pixel is greater than a threshold value, then we will set the value of that pixel as 255 or true value. And if the value of the pixel is less than a threshold value, we'll set it to 0. So what happens is all the pixels which are greater than the threshold value in that image will be converted to pure white, and all the pixels which were less than the threshold value will be converted to pure black. So you can see in the first image also, it is basically a result of a thresholding. And you can see that there are only pure white and pure black areas in this image. And also these two images are also result of thresholding, but there are different types of thresholding, which we'll discuss in detail in next slides. So we'll discuss mainly two types of thresholding. First is the global thresholding. It is also called simple thresholding. What it basically does is the same thing which I discussed now. Like if the pixel value is greater than the threshold value, it will convert it to pure white. And if the pixel value is less than the threshold value, it will convert it to pure black. Okay, in OpenCV, it is the function cv2.threshold that we use to perform thresholding. And the arguments you need to pass are the old image and the threshold value, which you will put yourself what threshold you want to place on that image. This value will be between 0 to 255, since we apply global thresholding on grayscale images only. And the next argument is a Maxwell. Maxwell means the value which will be assigned to all the pixels whose value were greater than the threshold value. Like in our case, we'll consider it normally to 255, so that we want to convert it to pure white. And the next argument is a flag. There are several flags when we apply global thresholding, but the very commonly used flag is cv2.thresh binary. And let me show you a demo of this flag. Yeah, you can see that first of all is the code. Let's see the code first. Yeah, we have implemented the function cv2.threshold. I pass the image, and the threshold value is 127. So basically, it's a midway value of 0 and 255. And I want to put the max value as 255, which means all the pixels which are greater than 127, they'll be converted to 255. And the flag is cv2.thresh binary, which performs the same task. Okay. And the result we get is binary thresh of that image. Now let's see the result. Yeah, you can see that in this image, all those pixels which were greater than 127, you can see that normally they're in the midway. The pixels which are more brighter, it means their values are greater than 127, so they're converted to 255. That is pure white, and all the rest of the pixels are converted to pure black.
Hey,
Now there
if
are
we want to change to white, then we will write 0 instead of 255.
Okay, don't think it like that. basically what we do is we convert it to a binary format, and since the image was grayscale, okay. So if I want to convert the value of the pixel to pure white, then I have to give it a value of 255 in order to convert it to pure white. Okay, basically after the conversion, the image will be of a binary kind, since it only contains either white or a black. Am I got you, or you have any other doubt?
Okay.
Yeah, cool. So yeah, we have several other flags using in global thresholding. You can see that here it is the original image, and this is the result of thresh binary, which is a binary thresholding. You can see that all the pixel values which were greater than the threshold value, they're converted to pure white, and all the pixels which are less than the threshold value, which are more near the center, they're converted to pure black. Thresh binary inverse is basically the inverse of the binary, and you can see that the results are also the inverse. It means that if the pixel values are greater than the threshold, they'll be converted to pure black, and if the pixel values are less than the threshold, they'll be converted to pure white. Now, thresh trunk is a truncated thresholding. What it means is, if the pixel value is greater than the threshold value, it will be converted to the value of threshold, and if the pixel value are less than the threshold value, it will remain same. You don't first of all, let me tell you that you don't need to remember all these flags and all these results, and you just mainly concentrate on thresh binary, and if you need any other flags someday, then you can just Google it. And 20 means thresh 20 means if the pixel value is less than the threshold value, it will be converted to pure black, otherwise it will remain same. And 20 inverse is basically the inverse of that 20. Okay, so don't need to remember all these flags. You can just use thresh binary every time, and if you need any other flag someday, you can just Google it out. Now, let's discuss the second type of thresholding that we use, that is called adaptive thresholding. In adaptive thresholding also, we'll discuss two types of adaptive thresholding. First is the mean adaptive thresholding, and the next one will be the Gaussian adaptive thresholding. Now, what is an adaptive thresholding? In the global thresholding, we provided the threshold value. Okay, but in adaptive thresholding, we don't provide the threshold value. What it does is, it will the algorithm will simultaneously determine the threshold value according to the neighborhood area of a particular pixel. Okay, so the threshold value which will be applied on a particular pixel will depend on how its neighboring pixels are. This results in a more better thresholding, and specifically in images which are clicked in like low lighting areas and with varying illumination, we prefer using adaptive thresholding on those images, since they give very good results on those kind of images. Now, in mean adaptive thresholding, we calculate the value of threshold by calculating the mean, that is the average of the neighborhood pixels minus a constant c. Okay, and the function in OpenCV is cv2.adaptive threshold, and we pass an old image, and we pass a Maxwell value, and we pass a adaptive thresholding type we want to perform. So here I pass it as cv2.adaptive thresh mean c. It basically means that same only, adaptive thresholding, that is the mean type, and cv2.adaptive thresh mean c. And next we pass is cv2.thresh binary, because cv2.adaptive thresh mean c will check how the threshold will be determined. And now we will perform a binary thresholding using that threshold value. So we pass cv2.thresh binary, and these arguments are very important. Like, the first argument is the block size area. The block size area basically means the neighborhood pixels that we want to consider, like how many neighborhood pixels we want to consider while calculating the threshold value. And the last argument, which is 2 here, is the value of this constant. Let's see a demo of this. Yeah, you can see that this was the original grayscale image, and this is the result of the mean adaptive thresholding. Okay, so you can see that how much the quality of image and has improved, and how much it has got more illuminated, more vibrant. Yeah, the next type of adaptive thresholding is Gaussian adaptive thresholding. It is basically similar as a mean adaptive thresholding. The only difference is that we don't calculate the average or the mean of the neighborhood pixels. Instead, we calculate a Gaussian weighted sum of the neighborhood pixels. You don't need to go in the details of how like Gaussian weighted sum is calculated and what are the formulas. But if you are curious enough, then you can just Google it out and you will get it. Or you can ask your mentors also. But it is simply a formula of Gaussian weighted sum, and which is applied instead of the mean formula, and we get the threshold value. And the basic difference on the code is that the flag it is changed to cv2.adaptive thresh Gaussian C instead of cv2.adaptive thresh mean C. The rest everything is same. Let's see what difference there is in between mean thresholding and Gaussian thresholding. Yeah, you can see that this was the original image. This is the result of mean thresholding, and this is the result of Gaussian thresholding. Gaussian thresholding generally is a more preferable, or it results in more better results while we use our adaptive thresholding. Any doubts till here before we go to masking? If not, then we'll continue with masking part. Yeah, in masking, what masking is basically, we try to prepare a binary mask on a RGB image or a colored image, you can say. What it basically means that we'll try to segment out a specific color from that image, that is create a binary mask for that particular color. In this image also, you can see that this was the original image. Then we applied a binary mask for the red color, and we got all the parts from that image which were red. And then we performed a binary mask for the green, and we got all those parts which were green. This basically means masking, and masking is always applied on the HSV format.
भैया बट वहां पे तो ब्लू के भी प्रिंट्स छूट गए ग्रीन मास्क.
Yeah, you're right. Okay, so when I calculated the HSV values for this green color, see, green and blue, or you can say these two shades are very similar or very close. That's why we generally prefer using HSV values while performing masking, because many colors are very similar in their values. Okay, so I did try to get the exact HSV values for those green. So it also got mixed up with the blue. Okay. I wanted someone to point it out. That's why I left it like this only. Now, how we do masking in OpenCV. OpenCV provides us a function cv2.inRange, and the arguments we pass in are the original image, a lower range, and an upper range. Now, what are lower and upper ranges? Lower and upper ranges are basically a NumPy array of the lower HSV values and the upper HSV values of a particular color. Okay, and remember that while using masking, it only accepts NumPy arrays and not anything else. Like you can't pass Python list or anything. It only accepts NumPy arrays. You will get to see this ranges in the code. Let me show you. Yeah, you can see that. First of all, I've converted the image to HSV format. So we have got the HSV format, and now you can see that I've applied the cv.inRange function, and I've passed two NumPy arrays as the lower and the upper range. These arrays are the lower and upper HSV values for that particular color. You can see that it is a lower part, HS and B, hue, saturation, and value, and this is the upper part of hue, saturation, and value. And let me show you the results of this. Yeah, you can see that this was the original image. This blue mask is a binary mask for the blue color. You can see that the blue mask is a binary image, and where it was blue, it is converted to white, and else everywhere it is black. And there is one more image which I showing you is the blue part, and it is basically the blue part of that original image. One interesting thing here which I can tell you is how we get the blue part. See, this binary mask, this blue mask is what you get from the cv2.inrange function. Okay, this is the binary mask. But if you want to get this thing, then what we do is we perform a bitwise AND operation on these two images. Now see, these images are basically you can say a array of values. Okay, so in this blue mask, all the pixel values will be 0 in this portion and 1 in this portion. So if I perform a bitwise AND between these two images, then only that part will sustain, which was this. Else everything will be converted to 0, and only this thing will get remaining. So that's how we get this blue part of that image. You can see that I performed this the cv2 bitwise AND operation on those images. That is the original image and the mask, and what I have got is the blue part of that image. Similarly, I can show you for the green and red as well. Yeah, you can see that you just need to pass the Hsv values of that particular color you want to segment out, and it will just give you the binary mask for that particular color. It is as simple as that. Now, before we move forward, if anyone has any doubts, tell here. Before we move to the surprise of this workshop, the content is over for this workshop, and if you want to ask any doubt, you can. Anyone, anything?
Did you understand one thing or other, or everything went over your heads?
Everything over the heads, भैया.
Yes,
Let's see. See, it's
Yes.
just there are a lot of
थोड़ा
functions
बस
and
आइडिया लगा.
कोड समझ में नहीं आया भैया.
ठीक है, लाइक ऐसे शुरू में थोड़ी सी प्रॉब्लम होगी. सी अभी कोडिंग से भी
Everything
तुम
just bounce over our head.
okay, yeah, it was kind of expected or more or less, so don't worry about it. See, it's not that hard. It only like one first time you are seeing it, that's why it's looking hard, but you'll see the video again, you'll see the workshop video again, you'll see some online resources, you'll find it to be comparatively easier at second time. So at first time these things tend to be a little hard, but don't worry about it. There is a lot of code and this stuff, and many of you are not familiar with coding yet that much. So it's nothing. It's just, that is a good thing about Python, that we were also like discussing about it in the last workshop, that it has many libraries. You don't have to do anything. You just have to call a function. There are inbuilt function and they'll do the stuff for you. So like, computer vision is very, very interesting thing. So you see Tesla has now like level 3 autonomy. So they are building autonomous cars. Google is working on autonomous cars. So they all use OpenCV, like computer vision kind of things, algorithms to solve their problems, to make their cars sentient, so they can sense their environment and drive autonomously. And in robotics also, like computer vision plays a very important role. Say you have a humanoid robot that wants to interact with an environment, that wants to pick an object, or that wants to traverse over stairs or over anything. So it needs to observe its environment. So that is where computer vision is used. So it forms a very intrinsic part of robotics and of other applications like autonomous cars and machine learning, deep learning. So it's very important, and you are just learning about the basics of it now. So you may seem okay, what we will do by thresholding colors, what we will do by detecting shapes, detecting colors, this and that, but it's not like that. You can't solve rotation questions without having the knowledge of Newtonian mechanics, right? And Newtonian mechanics are pretty basic, pretty simple. You'll say, okay, this is basic. Why do I need this? Just bring me hard problems. So this is not the way to go. First we'll learn about the basics, then we move to the hard things. So here you are being taught basics of computer vision, very basics. So you start with the colors, you start with the shapes, and then one day if you keep progressing in this field, you'll start detecting humans, start detecting other cars, and maybe working at Tesla or something, Boston Dynamics robotics company. So just don't worry about it. If you don't understand much of it, go through the workshops again, ask your mentors your doubts, There are many resources on OpenCV on the internet. There is like a very good playlist by Sendex on OpenCV. We'll share it in the group, Telegram group. You can look at that. And there are also other resources. So don't just worry about it, and you'll do it. And if it will seem hard at the first go, ask us. We are in third year. When we also like studied OpenCV for the first time, it looked okay. What is this, man? This crap, these functions all went over the head. And these second years would have the same experience. So don't be afraid. Keep attending the workshops. Before the next workshop, try to cover the contents of this workshop, and just watch the video, watch the recording again, watch some recordings on YouTube, playlist on YouTube that we'll share, and it will be clear in a day or two. It's not that hard. It's just for the first time you're seeing it, and it's something different. It's not physics, chemistry, maths. It's not computer science exactly. So it's something different out of your domain. That's why it's just seeming a little bit hard, but believe me, it's very easy. You'll go to the workshop again. You'll look at 1-2 YouTube videos. In an hour, you'll say, okay, I was afraid of this. I was not getting this. This is so easy. So don't quit thinking that it's hard or something or that. Just try again and you'll do it.
Yeah. So we'll be sharing all the codes and all the slides. You can just run the code on your system and you will see what the results are and you'll understand it. It's very simple and very interesting. So see, many of you are saying it went over your head, but I don't want any of you to lose interest. So let's see some interesting application of what I have taught you now. Okay, it's time for the surprise. How many of you are familiar with this picture? Just write in the chat.
Yes, yes, we are. Harry Potter.
Yeah, it's the invisibility cloak from the Harry Potter movie. How many of you are familiar with it? Just write in the chat box.
बताओ यार, इतने छोटे भी नहीं हो तुम कि तुमने हैरी पॉटर नहीं देखी होगी. 3 साल ही छोटे हो. हैरी पॉटर तो सबको शौक था बचपन में.
Okay, how many of you would love to have the invisibility cloak which Harry Potter had in that movie? Just raise your hands. Nice, nice. Okay, let me show you my invisibility cloak. Okay, be ready. This is a video which I recorded today only. Did it seem interesting? Anyone can unmute your mic and
It
say.
was so awesome. It was awesome, Bhaiya.
Yeah, मजा आ गया.
And what if I tell you you can also make one for yourself using only the knowledge I have told you till now in this workshop? Would it be cool?
Yes. Please tell.
Okay, so
Yeah, Bhaiya, please tell.
Yeah,
Please
using
tell.
color effect, you do so.
yeah, so see, I'll not be sharing any type of code for how to make this invisibility clock, but I can only say that it is just using masking operation on the video feed. Okay, so this I'm giving you an ungraded or a fun assignment, you can say, in this workshop, and you can just try it out and search internet like how to render a video feed using OpenCV and how to apply masking operation on that video feed, and how you can, and just try to get this results. Okay, so this is a fun assignment which I'm giving you today in this workshop, and it is not graded. You don't need to submit it anywhere. Just try it out for your fun and your practice. So that was all my part. Thank you.
Keep bugging your mentors, keep asking doubts in the Telegram common group to your mentors, and you'll learn it fast. It's something good, and it's very useful too. for your resumes, for your projects, for having fun, for making cool robots that drive themselves, that run themselves. It's a very important building block of that. So I hope I'll see you all in the next workshop also. That will be the last workshop, I believe, from our side, and then we'll release the problem statement for the event, and then the torch will be yours to carry, and you'll have to execute that and solve that problem statement and show us some amazing results. It'll be a fun problem statement based on the things you are learning. It'll be great. So, any doubts? Anything?
Yeah, I want to ask that in that next workshop, what it will be about?
It will build over this computer vision only, just the final tools, one or two more tools of computer vision that you will need. So try to go through this workshop once again and go through some YouTube playlists and stuff and get some clarity about the stuff that you have seen today. So we'll just be building upon that and giving you some final tools for the open CV, and then we'll have the event itself. That in that event you'll use the tools that you have learned in the first workshop for the simulation and the OpenCV thing. And once you do it yourself, it's very interesting. So you might see, okay, it's bouncing over heads. There are lots of function is scary, it's boring. But once you start doing it, like Aryaman showed, really nice example. Once you execute those things, it feels just so good that yeah, I am able to do something like that with my skills.
Okay, so it means a Pi Bullet and OpenCV on this two, the problem statement will be basically.
Yes.
Okay. Today there is any assignment?
Yeah, like Aryaman told you, you can try that, making that invisibility cloak. Search on the internet about basics of OpenCV and how to take on the video feed through it, etc., etc., and you can try to execute that.
And we have Pi Bullet, any assignment can you give us?
There is last year's summer camp tutorial on GitHub page of robotics. It had many basic assignments on PyBullet. We'll share that with you. You can do that to get proficient in PyBullet.
Yeah, it means it is in GitHub.
Yeah, it's on GitHub page of Robotics Lab. We'll share the link.
Share the link. Okay.
Okay.
For the
Anything
invisibility
else?
cloak, guys, don't try to just copy out any code from the internet or anything. Try to implement it yourself, even if you can't just ask commenters, or just try to search how you do it from it. Don't try to like copy paste any code. It's just for your fun only.
And also, if you do something cool with computer vision, feel free to share it in the common group. We'll love to see it. Everybody else will also love to see it.
Here we get some very complicated results in some problems of physics. So we can also stimulate in any Pi Bullet, that also.
Yeah, man, anything is like if it's related to the physical world and don't involve very complicated fluid mechanics, then it's like you can simulate in an PyBullet. You can even make your simulation. So PyBullet, a computer simulation is nothing but it just solves physics equations in the background and give you the results. So what you see visually at the back of it, just there's a bunch of physics equations, Lagrange equations and everything that you'll read in your second semester, I guess, first or second semester in your physics 1 or 2.
We have read Lagrange.
Yeah. So those equations are just running in the background and you're just seeing the results of those solutions only.
Okay.
Any other doubts? Anything?
How can we learn more about PyBullet and its working, and we want to, if we want to make a robot type project, how can we make?
Yeah, so for that only, for making you a little bit proficient in PyBullet, what we will do is we organize summer camp every year, and we teach you simulation in depth during that summer camp. So right now, this year, because of online, we have introduced the PyBullet earlier. Otherwise, we introduce it in summers only. But we have last year summer camp uploaded on GitHub. So we had I guess 5-6 assignments based on PyBullet alone on that summer camp in the tutorial of that summer camp. So you can go through them. We'll share the link, and you can try to solve those assignments to become a little bit more proficient in PyBullet. Then for now, the event will not need that much of the PyBullet knowledge. That's why we are not focusing on it. It just needs very basic knowledge. And once you go through this event, your summers are near, like you'll have a summer break. Then we'll organize a proper summer camp, and will give you knowledge about ROS controls and dynamics, how to make URDFs, how to simulate like complicated robots like humanoids and cart poles and etc etc. So there's a lot to learn. Let's go one step at a time. You can't go everything. Just give us. You'll half of the people will be scared away if we throw everything at you at once. So let's learn step by step, keep learning, keep growing, and slowly we'll move to more complicated and more exciting stuff. Starting from the basic is just a necessity so that you can later understand more complicated things. So we'll move to them, and they'll be a lot of fun. So, but for that you need to sharpen your basics first. So for that, I suggest you that solve the PyBullet assignments on the summer camp. We'll share the link with you, and just clear your concepts of OpenCV. They're not that hard. Bug your mentors, search on Google, and ask on a common group. Do anything, just keep asking your doubts and keep bringing in more clarity and knowledge for yourself. Anything else? Anyone? Or shall we call it a day?
One more thing I would like to say. You got most of you would be knowing that Technics is coming, and I can say that Robotics Lab has 2 to 3 events in Technics also, and the things we are teaching you for this event will be useful for those events also. And participating in Technics and completing the problem statements of events of Technics, it's a great achievement, and serve as a project for a resume also. So just try to learn the things we are teaching you now seriously, and then you'll be beneficial in that time.
Yeah, like we'll also have some prizes for the winners of the event probably, and Technics give very hefty prizes. Like I guess the winners get 6,000-7,000 rupees in online. In offline, we used to give more. I guess 10,000-20,000. So you can participate in the events and win for our college. Like there are a lot of colleges representing, a lot of teams representing different colleges in Technics. So you can participate, and there also your basic knowledge of PyBullet and OpenCV is needed and nothing else. A little bit algorithms you'll need to implement, and apart from it, just basic simulation and basic OpenCV. So do it now. Technics will also have its own workshop, but they will be more or less the same. So you can save your time then. Okay, I hope you people know about Technics. It's just that like in your college life, you'll go through 3 fests every year. I guess you are fresher, so you might not know it. So I'll just tell you, one will be your cultural fest. So it's called Kashi Yatra, KY, for our college. And in the offline, we used to have cultural competitions, say mimes and acting, drama, nukkad nataks and singing. So these competitions used to be there, and from our college, many students used to participate, and from other colleges also they used to come, and there were cash prizes for those who used to win. And at nights we used to have concert nights. So there are different bands and singers who come and they sing, and students attend and they dance. Like in first year during Kashi Yatra, we had Ritviz, the local train, and I guess Salim from like Bollywood performing in the college. So the big stars come. So similarly, there is Spardha. Spardha is for sports, and so we like have many competitions, almost of covering all the sports, and various IITs come and they take part. And those who play for our college, they play there, and those who don't play for our college, they go and cheer, they watch matches. It's very interesting and fun. So hopefully next semester Spardha is going to be probably offline in August. And then you have Technex. Technex is the technical fest. This also goes more or less in the same way. So you'll have your technical competitions based on like robotics club, aeromodeling club, co-ops, business club. So they organize their competitions, and from various colleges, many teams come to participate, and you compete against them and you win. And if you win, you get good prizes. And if it's offline, then the similar story as KY, we used to have 3 nights continuously, one after the other concerts. So many big stars came, like in Technics, I guess in first year, Zubin Nautiyal came on the third day, and on first or second day also we had some more other singers, Salim Suleiman, I don't know, like Shekhar, Vishal Shekhar, etc., etc. So yeah, once you come to college offline, fest form a very important part of the college. Like in first year Technics, we participated in Pixelate, and we spent almost a month preparing for that, making a robot and just running it there, tuning it, training it again and again. So almost 1 month we just kept doing that. After we participated in the Pixelate, we finished it, and then we just enjoyed the fest for 3 days without studying anything else, just roaming here and there. So a lot of colleges come, a lot of people come. So it's just like a festive season in the college, in the campus. So it's a nice experience. So hopefully next year I'll see you there.
भैया भैया आपको लगता है ऑफलाइन होगा?
अगस्त तो प्रोबेबली मान के चलो यार, इट शुड बी देयर। लाइक स्पर्धा अगस्त में होता है, तो स्पर्धा इस बार शायद ऑफलाइन करने की सोच रहे हैं। दूसरे कॉलेजेस तो लाइक बिट्स का मैंने सुना है, बिट्स इज हैविंग इट्स कल्चरल फेस्ट दिस मार्च offline, but it's only in-house. So usually fests are open to other people also, the college fest based on pass boarding, but they are having a internal fest like only for the on campus students. So in March, Triple IT Hyderabad has a cultural fest named Felicity. They are also having a offline in-house fest this year. So slowly we are transitioning back to offline state. So hopefully, let's see if next year we can have a fest offline.
यार टेक्निक्स में तो इतने सारे इवेंट्स है, लेकिन डेट्स बस 11 से 13 दिए हैं, मतलब 3 दिन में
Events
ऐसा
तो यार
कैसे?
आगे पीछे होंगे. Events will be scheduled. They will not clash with each other. The events will be scheduled a week before that, over a full week. So those 3 dates are like fests are usually held at weekends because of those concert nights and everything. So we just give those 3 days for that purpose. But the competitions and everything, especially in Technics, are wrapped up before that or after that. So they won't clash.
अच्छा,
Don't worry. But still take limited part, like having taken part in 4 or 5 events and not doing any of them properly, that's not a good thing. You are taking part to learn something, to grow yourself. You're not taking part to just get certificates and for the sake of participating. So I guess 1 or 2, 3 events at max are manageable. So just see how much you can manage and take part, choose your according to your interest, and take part in limited events, the like number of events
and
you can handle.
yeah, there will be separate workshops for each event, right?
Yes, in Technics, there will be workshops for each event. I guess workshop schedule will also be released in a few days for Technics.
भैया registration
Okay,
has
yeah.
started for Technics?
Not yet, I guess. They have just released the events, name of the events, and the workshop schedule will be released. When the registration starts, you'll get the information. It is just on a website will be created and you'll have to register there.
Okay. No website has been created.
No, I guess I don't
No,
think so yet. It has been out.
no website has been created.
Yes,
भैया.
भैया, it is created.
Okay, okay. So you'll get notification in your groups also once the registration starts, and the link will appear on the website itself to register whenever the registration starts. But they haven't started yet.
Okay.
Okay, then I guess we can call it an end, and let's see you in the next workshop. All the best. Take care. Thank you for attending. You all can leave.
Thank you भैया.
Thank you, भैया.
And special thanks to Ariman and Netik for having an amazing workshop.